Hello. Uh, okay, so welcome to Code Catalyst. I'm recording maybe like 3 hours after camp ended. Yeah, so the audio messed up, and I'll just redo it right now. So hi, my name is Alex. Welcome, blah 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 blah. Okay, about Java. If you have already downloaded Java, great. Use your IDE if you're using like VS Code, IntelliJ, uh, Eclipse, Vim, etc., etc. If you haven't, that's also fine. Uh, REPL isn't too hard to set up on your own. It's just like a basic website. You create your account, you log in, etc., etc. So it shouldn't be too hard. And then after you're done setting up, write your first program. So preface, computers store data as ones and zeros, basically in binary code, machine code. One represents an on value for the transistor, zero represents an off value. Each one or zero is a bit, essentially. The ones and zeros can represent anything, colors, sounds, this computer screen, this slideshow, etc. And quick conversion, 8 bits equals 1 byte. And that's really important because we're going to talk about primitive data types. There are 8 primitive or like fundamental data types in Java. And essentially, primitive means it has like no additional methods attached to it. It is a fundamental building block of Java. It is built into Java and not created by another developer. And essentially, this can be deduced. There are 8 primitive data types, and that's a byte, which is 1 byte or 8 bits, a short, ints, and longs. They basically represent the same thing, but like different ranges. Integers are just whole numbers, or signed whole numbers. In this instance, shorts are like integers, but just have a shorter range, and longs are also like integers, but have a much larger range. And then floats and floating point numbers and doubles uh, are also represent the same thing, essentially like decimal point numbers, not whole numbers, and floating point numbers just have a smaller range. And you also have to indicate that they are floating point numbers basically by having an F, like uh, yeah, let's just do that. Whatever. It doesn't matter. Yeah, you have to like declare it like with an F. And then doubles, you don't have to like indicate it with an F. It's a double. It has a larger range. And yeah. And then booleans are 1 bit. They're just simple true or false values. And then chars are just characters. It's a single ASCII character. So, uh, variables. Basically, variables are data containers that hold like a specific value. It essentially reserves a specific memory location to hold data and labels it. It's useful for labeling values with descriptive names. Useful if you use the same value many times in a large file and want to change all of them at once. Let's say I wanted to make like a poem or something, and I wanted the name Alex to be repeated over and over again. Instead of like individually like having Alex, Alex, Alex throughout like the poem, I can just set a string variable name to Alex in double quotes. And essentially I can just replace all those instances of Alex with the name variable. And what makes that really nice is instead of like individually changing, let's say if I wanted to change the name to Ashwin, instead of changing all of those from Alex to Ashwin, I can just change the name variable from Alex in double quotes to Ashwin in double quotes, and it automatically changes all of those. So it obviously like reduces your workload, makes everything much easier to essentially like refactor, and it's just better. And essentially, Java is a statically typed language. It's very important, unlike Java or JavaScript or Python or some other languages that you may be familiar with, meaning you have to explicitly indicate the type of every variable, method, etc. declared. And essentially, this is the formula for declaring a variable. You have to have the type, or like int, boolean, char, etc., the name, and then the value. And then you have to have a semicolon at the end because we're in Java. And you have to end your statements with semicolons. So other syntax for declaring variables, you can just declare the variable and then initialize it with a value like that. Constants. So sometimes you just want a constant value. You don't want it to change. Like maybe it's a mathematical constant like pi. It's always going to be like 3.1415, blah, 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 blah. And so to indicate that you don't want it to change, you want it to be a constant, you need to have the final keyword before the declaration. You see here we have final, the type, it's going to be a double in this case, and then pi, and that the pi is going to be in all caps because that's just like a naming convention that all constants should be in all caps. And then we have the value 3.1415, whatever, yeah. Yeah, and again, constants, they cannot be changed. After you declare them, or like after and initialize them, you cannot change their value. So yes, that is very important. Legal and illegal identifiers. Identifiers are essentially the names for variables, methods, etc. And certain names are not allowed in Java. Illegal starts with the number 1 ABC, contains spaces, myvar. Instead of spaces, you can just have an underscore, a single underscore. Uh, contains hyphens, contains dollar signs, double underscores, etc. So it's pretty simple, just keep single underscore are allowed, all of this is not allowed. And also reserved keywords like that are already defined in Java, like int, static, void, etc. These have predefined meanings in Java, and they're not allowed because the JVM could easily just confuse them. So yeah. And here we have all of the keywords. All of the keywords in red are specific data types, and yeah, you'll learn a lot of what these mean later on in the session if you decide to keep up with us. So yeah. Good naming conventions. You should generally, well, yeah, you should always follow camel case. It's the industry standard for naming your variables. And camel case is like you want to, let's say your variable name is multiple words long. Uh, like my name is. You want to the M in my to be lowercase. And then for every successive word, you want the first letter to be uppercase. So the M in my is lowercase, the N in name is uppercase, and the I in is uppercase. And you can see here that it's like birth year. The B in birth is lowercase, the Y in year is uppercase. And you can also see here, the M in my is lowercase, variable, the V in variable is uppercase, the N in name is uppercase. And yeah, and it's better than just like naming it X or Y or I, for example, because it's like descriptive of what the variable stores and does. Meaning like if someone who didn't make this, if someone besides you looked at your code, it'd be easier to look at because they're given a clue about what it does. And avoid using abbreviations and acronyms unless they're well known. Keep variable names short. Yeah, pretty self-explanatory. And typecasting. So typecasting is essentially when we want to convert one data type into another. Let's say we wanted to convert like an int into a double, or yeah, or like an int into or a double into an int, et cetera, et cetera. And there are two types. Widening casting essentially converts smaller types to larger types and are done automatically. So if we look previously, there are different sizes for each different data type. And widening means we want to go to a smaller data type, like an integer, which is only 4 bytes large, and go to a larger data type, like a double, which is 8 bytes. And that's called widening. It gets wider, it gets larger. So, and you can see here it's done automatically, like we don't have to have any indication, just set the double variable, double example to int example, and it does that automatically. Narrowing casting is different. Narrowing casting converts a larger data type to a smaller data type. For example, where we can convert a double, which is 8 bytes, to an integer, which is 4 bytes. And narrowing casting is essentially done with, and you have to manually do this, you have to set the type you want to convert to in parentheses. And I made a little mistake here. It shouldn't be a 3, it should be a double example. So imagine like int int example equals this, the int in parentheses, double example. And that is narrowing casting. It's making the data type, it's converting the data type to a smaller data type, essentially. And you have to do that manually, convert to winding casting, which is done automatically. And here you can see the formula, the convert type in parentheses, and then the original data. And then, yeah, you can see here, pretty self-explanatory. Yeah. Well as, yeah, yes, wrapper classes. So wrapper classes are really pretty important as you go on later, maybe when you're talking about generics, array lists, etc. Basically, data types are just data types, and they hold data. Besides that, they don't really do anything else. And wrapper classes, which are like the data types, but the first letter is uppercase, like integer, double. Uh, the wrapper class for chars is character with the C uppercase. It allows us to perform various methods onto their respective data types. For example, integer parse int string s converts a string to an int primitive, uh, and this is important. Like, let's say you had the string was like 3 in double quotes. Yeah, like the number 3 in double quotes. If you added a string with an integer, that would result, instead of like adding like 3 in double quotes, that would instead of resulting in like 6, if we added 3 in double quotes plus 3, it results in 33. And that's not good. So we want to convert or like typecast that string into an integer via the dot parse int from the integer class. And you can find more information about wrapper classes from websites like Geeks for Geeks uh, and as well as other websites. And then homework, use REPL. Yeah, it's pretty simple. And yeah, sorry for messing it up earlier, but hope this suffices. And again, if you have any questions, uh, DM us on Discord, uh, yeah, or just ask in the general channel, Q&A channel, etc. So.